Okay. Now this is also why I should not be initialized to 0. Because if I was initialized to 0, then I minus 1 would be -1, which is not a valid index into an array. In other words, with this algorithm, you have to give it the first prime number. It will work from there and up. Oops. Okay. Revision 6. What do we do after this? In other words, this is going to be my focus. This is my focus right now, is I know what number I'm supposed to start with. In fact, I made a mistake because I should not be starting with a bracket I minus 1. It is already a prime number. I should start with a bracket I minus 1, the whole thing plus 1, because that will be the next available number. That cannot be a prime number, but I know that this is the next number that I should start with. Okay. Is that a repetitive process? Okay, this statement all on its own, do you think it is a repetitive process? In other words, if I tell you that the last prime number was 17, okay, I want to find a prime number that is greater than 17, the next available prime number, do you think it's a repetitive process?
No, not the next one. Yeah. You would stop right there.
Well, but 18 is not a prime number. So it is still a repetitive process.
Yes.
But 19 would make it more obvious because the next prime number after 19 is 23. So you have to try 20, 21, 22, and then when you're up to 23, then it is done. So the fact or the act of trying to find the next available prime number is a repetitive process already. So that means you have two choices now. You can either, quote unquote, contract it out and do it later, or you can do it in line, within this portion of the program. I'll just go ahead and do it in line. So basically, I know that I have another loop inside here, loop and loop, exit when the next prime number is discovered. Okay. And then what do we do? Okay, we'll call it a day.
Do we need to declare a variable for the prime number?
Yes, we do, but I'm just trying to capture the concept, the idea first, and then we'll focus on the names and the variables and stuff like that. Okay. Now, how do we confirm a number is prime? Okay, so here we have to say. Now, the first thing I can do is to say a bracket I gets a bracket I minus 1 plus 1. Because we know that we have to start with that value. That's a starting point. Now, once that we know that this is the starting point, we can also express this thing here as exit when a bracket I is prime. What do you think we're doing inside the loop here? If a bracket I is not prime, what are we going to do to a bracket I? We just increment it. We just add 1 to it, try again. Is it prime now? No, it is not prime. Add 1 to it. Is it prime now? Yes, it is prime. Then we can get out of the loop. So now we say a bracket I gets a bracket I plus 1. Okay? Now, I don't know exactly how I can determine whether a bracket I is prime, but I know this is what I want to do. So once again, we are using top-down design. We're focusing on what we want to do, not knowing how it is done, so that we can just capture that idea first, and then later on when we have time, then we can spell out exactly how it is done. Okay. When you look at the algorithm at this point, does it make sense? It still makes sense, right? I mean, if you look at the entire algorithm, the outer loop is saying, okay, a bracket I starts with the number that is following the previous prime number that I have found so far. We have an inner loop inside here. The inner loop is going to keep adding 1 to a bracket I until a bracket I is a prime number itself. Seems to make sense to me. And then back to the outer loop, once I have discovered the next prime number, I add one to I, which is an index, to the element in the array, and the outer loop itself will exit when I have filled up the entire array, because I'm filling up the array one by one. So far I can go back and check and say, okay, does the overall code still make any sense? And the answer is yes, it still kind of makes sense. At this point, the biggest hurdle, the biggest obstacle is how do I decide a bracket I is a prime number? Do we have any mechanism to determine that a number is prime number? Remember what we did earlier in this class? Okay, we can try to find a prime factor. If we cannot find a prime factor other than the number itself, then the number is prime. So we can borrow that code here. So that means when we work on revision 8, we have to introduce yet another loop. Okay? Because the other loop is going to be stuck here. Determine whether a bracket I is prime. Okay? So I'll just need to put this as our revision 8. Because this is significant. Okay, we have to put this logic inside here because there's no operator that can determine whether a number is prime all by itself. We call this revision 8. Now we're up to revision 9. I hope you guys are seeing that I don't write an algorithm from top to bottom, like just sequentially line by line. I make an algorithm by using the top-down design approach and also adding just a little bit more logic each time. And it is also helpful to keep a history of the evolution. So in case of any trouble, I can backtrack a few steps and say, okay, I don't want to start from scratch again. I know I was right up to like 2 steps ago, and I can just go from 2 steps ago and forward again. Okay, determining whether a bracket I is prime or not. I think we have seen that logic somewhere. Okay, so we'll go ahead and just kind of copy that logic here. At least a good portion of that. Because that logic seems to have to do with something about f gets initialized to 2, while n, or in this case a bracket I, mod f does not equal to 0, and f times f is less than a bracket I. Basically, a bracket I is taking the place of n in the previous algorithm. Okay? So we do the same thing here. F gets f plus 1, and while. But tech, this code does not really determine whether a bracket I is prime or not. Well, it does not by itself, but it does get out with a certain indication. If a bracket I is in fact prime, what condition has to be true? Remember the theorem that we spent so much time to prove, and how we utilize that that theorem to optimize the previous pseudocode to find a prime factor. So what is an indicator? How should I replace when a bracket I is prime? Using the relationship between f and a bracket I. How did we do it before? Nobody remembers. When f times f is greater than a bracket I, that's the indicator that a bracket I is prime. Because previously, when f times f is greater than n, it implies that n is prime. In this case, we don't have n anymore. A bracket I has taken the place of n. So that's why in this case, we change it so that this is now when f times f is greater than n.
A bracket I.
Oh, a bracket I. I'm just trying to see if that is the case.
Yep, I think that is okay. Do you guys have any questions? No? Okay, could you please kind of stop that? Thank you. Okay, so are we okay so far? Can you guys link the previous generation of this code? Can you link revision 8 to revision 9? Because that's probably the biggest jump so far, is how do I apply this code that we have seen before and apply over here just to determine whether a bracket I is prime or not. Okay? Because in this case, I'm not interested in finding a prime factor of a bracket I. I'm only interested in determining whether a bracket I is prime or not.
So you exit
when it is prime. Because when f times f is greater than a bracket I after that loop, it implies that a bracket I is a prime number. If it is not a prime number, if this condition is false, then we are not exiting. We go back and then we do this whole, we go back to here and we add 1 to a bracket I, and then we test whether that new a bracket I is prime or not.
Yep.
Okay? And you have to remember, f gets 2 has to be inside here and not outside, because otherwise, it won't get properly reinitialized. Okay, this is revision 9. Let's go to revision 10. Oops, forgot to copy the separator. Or I did copy it just at the wrong place. Revision 10. Okay, in revision 10, we want to determine whether these loops should be pre-checking or post-checking. What do you think? Let's take a look at the inner loop first. Should this one be pre-checking or post-checking? That's a trick question. Remember, most of the time we want pre-checking loops. In this case, can we use a pre-checking loop? In other words, the condition involves what? F times F in the comparison to a bracket I. A bracket I definitely starts with a particular value. What about F? Does F start with a specific value before the loop itself? No. So that means in this case you have to use a post-checking loop. There's no way you can use a pre-checking loop, because there's no way to determine what F is before this code executes. Yep.
Could you not just assign a value at the very top of the pseudo code?
No, you cannot, because in this case, f is used as an indicator of whether a number is prime or not.
Right.
So you can only utilize the value of f after, okay, just hold on a second. You can only utilize the value of f only after this code. You have to run that code first before you can use the value of f to indicate whether you have to go back and do it again. So that's why in this case, you have no choice but to utilize this particular method. The other thing I think has to do with this line here. Because this is a post-checking loop, it also means that we only have to do this part here. We don't need to add 1 before the loop, because this is a post-checking loop. I'm guaranteed that a bracket I will be 1 more than a bracket I minus 1 before the code will determine whether it is prime or not. And in fact, if I put a plus 1 here on the blinky line, at the blinky cursor, it would be wrong. It would actually skip over one of the potential prime factors. Okay. So we.
every time.
Sorry.
It would go up twice every time the loop started.
No, it's not like that. It would just miss 3 as a prime number, because 3 is the prime number that's right after 2, and it would have missed it if I did it that way. So we are now up to revision 11. Revision 11 is going to say, what about the outer loop? Should I use a pre-checking loop or a post-checking loop for the outermost loop? What do you guys think?